Okay, so we're starting Unit 3, and Unit 3 is all about linear expressions, and specifically Unit 3 is going to be writing these linear expressions in different ways, in different terms, and you should be able to rearrange the equations of a line in one way and identify the way they are written in certain different ways. Okay, so what do I mean by a linear expression? Well, you can see that linear has the word line in it. Linear as in a straight line. Okay, so you can tell a linear equation is a straight line because each term the variable is only raised to the first power. Okay, so for instance, a linear expression is an expression or an equation. What's the difference between an expression or equation? Well, an expression, for instance, is like 3x minus 4y equals 8. Okay, the expression is 3x minus 4 or 8. Okay, the equation is 3x minus 4 equals 8. Okay, an expression is like part of a sentence. That's an expression. That's an expression combined together is one equation. Okay, a linear expression is the term or a constant has nothing higher than a degree of 1, meaning the exponent, nothing has a higher exponent than 1. Okay, and this as a result of a straight line if you were to plot it on a coordinate plane. Okay, and what you see here is written in standard form. Right, and you know a term is written in standard form because you have an AX plus a BY B, another color here, BY equals C. Right, C is my constant, so I need another color. How about red equals C? Okay, two coefficients, right? A C and a Y. I guess this should be blue and that should be green. But so a coefficient in a variable term, coefficient with another different variable term, and then a C. Okay. And these A and B's are rational numbers. C is a constant, and A and B are not 0. So that's that with this. Okay. So if I rearrange all this to to make it like so that I have y equals, right? So if I rearrange this, let me rearrange this algebraically. Okay, so if I rearrange this and I was like, okay, let me subtract a from both sides, ax from both sides. So it's gonna be b. So I'm gonna rearrange b equals by, excuse me, by equals, and then it's gonna be negative ax, negative ax, ax plus c, I'm just solving for y right here. Okay, and then I'm going to divide both sides by b, right? Got to divide both sides by b here, and I'm going to be b or y is going to be equal to y equals negative negative a over b x, right, plus over divided by c over b, right, over b, right. Okay, so depending on what these numbers were, right, I'm gonna get a whole number, and I'm gonna get a whole number here. We're just gonna call this whole number. I'm just gonna call this number b, okay, lowercase b, right, and instead of this negative a over b, depending on what these numbers were, this a over negative a over b, this is something else that I'm going to explain here in a second, but I have a number, right, an a over b. I'm going to explain what this is here in a second, right, but this y, I'm just going to change this to m, and I'll explain what m is here in a minute. mx plus b. mx plus b. Okay, so this y equals mx plus b. Okay, this is called point-intercept form. Point-intercept form. Okay, and we'll discuss point-intercept form here in a moment. And then, if we were to take this this thing here, and we'll get to a point-slope form here in a minute after we explain what slope is. Okay, so let's get right away to what slope is. That's what this m is. M stands for slope. M is the slope. Okay, so let's say I have a slope of a line. Okay, now let's say it's, I don't know, it's like this from here to here. That's the slope of my line. Okay, and it goes through 2 points. We can just pick any 2 points really what it goes through. Let's choose like this point here, and let's say another point that it goes through, this point here. That's where it intersects these 2 easy points to count. Okay, I could have chose this point here, I guess. Not really. That's a good point there, and that's a good point there. Say it goes through those 2 points, right? And I want to figure out what the slope is. Okay, the slope is defined by the change in y divided by the change in x, and that's what that triangle means. This is delta. This is the Greek letter delta, right? And delta in both math and in physics is change. Okay, and changes can be positive and changes can be negative. Okay, well, if you have a positive slope, it's going to slope upward from left to right. If you have a negative slope, it's going to slope downward from left to right. So this I can already tell just by looking at it is a positive slope. Okay, but mathematically, how can I tell? All right, so let me look here. I'm going to figure out what my change in y is from this point to this point. Right, so from this point to this point, my change in y goes from here 1, 2, 3, 4. My change in y is plus 4. Okay, and then my change in x is 1, 2, 3, 4, 5. My change in x is plus 5. Right, so my slope for this, my m value, is 4/5. Oh, sorry, that's wrong. Is, no, that's right. That's right. Is 4/5. 4/5. Right? It's 4/5, and so in this equation, it's going to be 4/5 x. So m equals 4/5 4/5. So my y value, so y equals 4/5 x. Okay, but what is b? Well, you notice here that I don't have a coordinate plane. It's just some line out in nowhere's land, right? So in order to figure out what b is, I need to have a origin, right? So let's say I have my origin, and let's say it's like right here. Okay, let's make an origin. And let's put like my origin right here. Let's put an origin right there. Okay, and let's make it my origin. Let's make my origin right here. Let's put my origin right here. That's my origin. This is 0, 0. Okay, this is my origin. So this is my coordinate plane, my x and my y. B in here, I'll go ahead and continue my line this way, going on for infinity. Right, x and y going on for infinity. So my b value is where this line intercepts my y axis, right? So it's going to be y equals mx plus b, and b is going to be 1, 2, 3, 4. So y equals 4/5 x plus b. So this equation tells you multiple things. The sign of my x value, which is positive here, you just can't see it, tells me that the slope of my line, it goes like this. The 4/5 tells me the magnitude of the slope. For every change in 4y, it goes 5 this way. Okay, x, right, 4/5 x, right? So for every change in 4x, there's 5. For every change in 4x, there's 5 changes in y. Or 4 changes in y, there's 5 changes in x, right? And then there's going to be a +4 shift, a +4 shift upwards in my line. Because if it was 0, it would just cross through the 0 line. If I move it up +4, because if it was, this is y equals 0, right, it would just be at the 0 mark. But if I add 4 to it, it would shift 4 upwards. Okay, so that is that. Okay, so that is the point intercept form and the standard form. And we're going to get to the point slope form here in the next video. Actually, we're going to go ahead and use this video to demonstrate the point slope form too. So the point slope form says for any point of y. So let's maybe demonstrate it like this way. I have 2 points on a line. Okay, and we'll call one y sub 1 and x of 1. Maybe it'll be maybe, let's see, I had a good point on here, like this point. Call this one y sub x of 1, y sub 1. Okay, and then we have another point, and we'll call it maybe how about this one? This is fine. We'll call this one x comma y. All right. So we can say that the points. Here we go. 2 open parentheses, close parentheses equals the slope times open parentheses, close parentheses. Now we're going to fill in this thing here. Now we can say that so this is 1 point, x of 1, y sub 1. Okay, there's just different ways to to identify these 2 points. One's red, one's green. All right, so our initial point, we'll call this one red, our y points, and our x points, okay, minus our y sub 1 points and our x of 1 points. Okay, so the y sub x, the y minus the y sub 1, so the y values of these minus equals the slope, our 4/5, times the x minus the x values of these. Okay, so you're just looking at the values, and you could name these x sub 1 and this one x of y sub 1, or you could name this one x sub 1 and y sub 1. It doesn't matter as long as you don't mix up the x's and up the y's. You could have named them anything. Okay, so say I don't know this point, right? But I know this point is, we know this is 4. We know x is 0, and we know that y is 4. Okay, and we're trying to figure out this green point right here. Okay, so we put in our values for our red numbers. Okay, so we'll be able to get at least some of the information here. Okay, so we're going to put in 0. Our y value, or our x value for this one our y value is going to be 4 minus y sub 1 equals our slope of 4/5. Okay, times our quantity of our x value, which we know is 0, minus our x sub 1 value, minus our x sub 1, which is green. X sub 1. I should have made this green up here. Minus x sub 1. X sub 1. Okay, so now we can rearrange our equations, and we can maybe solve for some stuff here. So this is how we can do some things here. Okay, so let's see what we can do here. All right, so first we're going to distribute this 4/5 into our polynomial over here. So 4/5 times 0 is going to be 4/5. Correction, 0, and then 4/5 times negative x is going to be negative 4x over 5. Okay, and then over here we're going to have our minus 4 over y sub 1, and it's going to be equals this. Okay, so now the 0 is gone, right? So we can just erase this 0 here, and this is what I have here. Okay, so now I can move this y. I'm actually gonna move this y over to here, so it's gonna be y. It's a negative y, and I'm gonna move this negative 4x over 5 to say equals. Yeah, that's gonna be confusing for you guys. So I'm gonna say y equals 4 plus. Let's keep the numbers the same color. 4 plus, and then this is going to come over here, become plus 4x over 5. okay, or 4/5 x over 5. So that equals this, so this is the same thing, y equals 4/5 x, 4/5 x, 4/5, 4/5, 4/5 x plus 5. Right, so we got the same equation that we knew, whoops, plus 4. So we've determined that this is indeed the same equation for our slope, y equals 4/5 x plus b.